Okay, so I want to look at a few extra examples of real numbers and the number line because they're a little bit more complicated than the integers and the natural numbers, the counting numbers. So there are a few things we have to watch out for. So I'm going to do an extra example, plotting a few different inequalities on the number line. So represent the following inequalities on the number line. Okay, the first one is x less than or equal to 3 and x an element of R. So x is a real number, including all decimals. The second one we're going to do is a strict inequality. So x strictly bigger than 2, can never be actually equal to 2, and x a real number. And the third one we're going to do is a combined inequality where x is between two numbers. So the way we're going to write it is minus 2 is less than or equal to x, which is less than 3. So even when we're looking at that there, we can see that x is between minus 2 and 3, but it can never actually be equal to 3, and it can be equal to minus 2. So these are the three examples, these are the three inequalities we're going to plot on the number line. The first one, x is smaller than 3. So let's sketch a number line, and of course it's the real numbers, so it goes on forever in both directions. And we just have to make a decision about what numbers we'll include. So we must include 3, and I'll normally go 1 or 2 either side of that. So 5, 4, 3, 2, 1, 0, minus 1. I don't even need this many numbers, but this is good enough for our notes copies anyway. Then I look at the number that I want to represent, the number 3. Okay, and I find that on my number line and I check, can x be equal to it? And with that little line underneath it, I can see that yes, x could be equal to 3, and it could be equal to all of the numbers that are smaller than 3, including the decimal ones. So I'm going to colour in the number line from 3 down, all the numbers that are smaller than 3 going this way, and every number going on to infinity in that direction. So that's how I represent that inequality there. And you can see the inequality itself gives me like an arrow pointing the direction that I need to go. Let's look at the next one, because that one didn't look too hard, right? That didn't look too much different to what we'd already done, but I said that real numbers are a little bit more complicated. So the next one here, again, I've got to include the number 2. So I'll go maybe again minus 1, 0, 1, 2, 3, 4, 5, and I fill in my arrows. Okay, so here's my number line, and I've included the number that I need to represent. So again, 2 is the number I'm looking at, and I find it on my number line. But there's something different now. X can never actually be equal to 2, but it could be equal to 2.1, or it could be equal to 2.001, or any number, any decimal number that's bigger than 2, but infinitely close to it. So I represent this, my strict inequality. I represent it with an empty circle on the number. So that empty circle is illustrating that I can't be equal to 2, but I can colour in the line infinitely close to 2. And again, my inequality is pointing this way, so it's the numbers bigger than 2, including all the decimal numbers that are bigger than 2 as well. And I colour in my arrow to indicate it can go on forever in that direction. Okay, so in this case, I didn't have a strict inequality. It could be equal to 3, so I colour in the dot. This one, I do have a strict inequality. It can't ever be equal to 2, So I put an empty circle on that number, but I colour in the line in between all the same. Now, let's look at this one, a combined inequality. Okay, so this information here tells me that x is between -2 and 3. But what else is it telling me? X can be equal to -2, but x can never be equal to +3. So let's start here. -3, -2, -1, 0, 1, 2, 3, 4. Okay, so I've got my two numbers contained in here and an extra number either side of it just for good measure. What do I do here? I find my two numbers. So -2, I found it, and I can be equal to it, so I'll do a coloured in dot on it. +3, I find it, but x can never actually be equal to it, so I put an empty dot on that. And then my arrows tell me, what? Well, the arrows kind of look a little bit different to what we're used to when we write x first. So this says that x is bigger than -2. I actually have to go in this direction. The easiest way to read this is x is between -2 and 3. Or we can rewrite our inequality in two parts, if you're not sure about which direction to go, and write this as x is bigger than -2. So that's telling me to go this way, from -2. And x is smaller than 3, which is telling me to go this way from 3. And that helps me to know that I've got to colour in the space in between them. And that's how we represent a combined inequality like this on the number line. X is between -2 and 3. It can be equal to -2, and it can't ever be equal to 3. So hopefully you understand all the different symbols and how to represent the different types of numbers on the number lines, and I'm going to ask you to practice with a little bit of that today. Okay, thank you.